Hi, this diagram is meant to show the different carbon definitions in design. It's turned out a bit more complicated than I expected, so let me talk you through it. If we start with a timeline for a project along the x-axis. In the first stage of the life of a project, the emissions are from the manufacture of the products needed and the construction of the building. After that are the emissions from the building in use, from repair, energy usage, and water. As a planet, we have a limited time to make the changes needed to avoid a climate catastrophe. And offsets are important, but they take time to actually capture carbon. For this diagram, the y-axis shows carbon emissions. The higher up the graph from the timeline, the more carbon that's been released. The lower below the timeline, the more carbon that's been captured. Over the lifetime of a project, there might be times when the total emissions in that year are positive, and other times when they're negative. But in order to limit climate change to 1.5 degrees, we need to limit carbon emissions, and these limits will get lower over time. So there are different types of design. At one end, there is climate denial design, which ignores any limits and releases carbon as if nothing has changed. There is carbon neutral design, which balances its emissions with carbon capture. Without limits, those emissions can be huge and will be in the atmosphere at the turning point before they can actually be captured. There is net zero carbon design, which limits emissions in the first place and uses offsets for the residual emissions. This is where all projects should be now. Going further is absolute zero carbon design, where all the emissions are eliminated without the use of offsets. Some would argue projects like this would stay zero throughout their life. I think a constant zero is difficult and think it might start negative and tend towards zero. Then there is carbon negative design, where the emissions remain negative over the lifetime of the project and the building is a carbon store. Lastly, what we should all be aiming for is carbon capture design, where the project captures and stores carbon over its lifetime. This is the real aim, architecture that doesn't contribute to the climate emergency and also helps address it. Hopefully that makes a bit more sense now.